Hi everyone. I hope you're okay. It's the seventh video from the promised videos of answering question papers. If you are new to the channel, guys, firstly, before you subscribe, just go and answer and watch the first video whereby I'm answering the first questions. Because if you're coming for the first time here, this is the seventh video, guys. Don't forget to subscribe if you like the work we are doing, what look like, and share so that we can grow the channel. Okay. The reaction between sulfuric acid solution and sodium hydroxide solution is investigated using the apparatus illustrated below. We have a retort stand, a burette. Inside the burette we have an acid there. There's an Erlenmeyer flask, and inside the flask we have sodium hydroxide. Okay. Write down the name of the experimental procedure illustrated above. In this reaction, guys, they are mixing sulfuric acid and sodium hydroxide. So this type of a reaction is called titration. All right, together. What is the function of the burette? Remember that, guys, inside the burette we have an acid inside the burette. So the function of the burette is to measure the exact number, the exact volume rather of the acid that is needed to neutralize the base. Define an acid in terms of Arrhenius theory. An acid is a substance that ionizes in water to form a higher concentration of hydronium ions. Okay, give a reason why sulfuric acid is regarded as a strong acid. Sulfuric acid is regarded as a strong acid. Why? Because it ionizes completely in water. Okay. And then we are being asked, bromomethyl blue is used as an indicator. Write down the color change that will take place in the Erlenmeyer flask on reaching the end point. On reaching the end point, choose from blue to yellow, yellow to blue, green to yellow. We are told that they are using bromomethyl blue together, so the color change will be from blue to yellow, the color change of the indicator. Okay. During the titration, a learner adds 25 cubic centimeters of sodium hydroxide of concentration of 0.1 mole per cubic decimeter to an Erlenmeyer flask and titrates this solution with sulfuric acid of concentration of 0.1 mole per cubic decimeter. The balanced equation for the reaction that takes place is given below. Determine the volume of the sulfuric acid which must be added to neutralize sodium hydroxide in the Erlenmeyer flask. Since we are told that, guys, there will be neutralization, we can simply use our titration equation, that CA VA is equal to CB VB. Okay. If my acid is substance A and my base is substance B, I can simply say the concentration of my acid, I know it's 0.1, but I do not know the volume of the acid. Are you together? But I know the concentration of my base is 0.1 and the volume of my base is 25 cubic centimeters. Please, guys, I still repeat this. Na and Nb do not represent the number of moles. However, they represent the stoichiometric coefficients. Are you together? The acid has a coefficient of 1 and the base has a coefficient of 2. So for me to find the volume, mathematically these two will just cancel one another. I'll simply cross multiply the remaining ones. I'll have 2 volume of an acid equaling 25. Then whenever I divide to 25 by 2, I'll simply get 12.5 cubic centimeters. The volume which was needed to neutralize the base, the volume of the acid H2SO4 that was needed, it's simply 12.5 cubic centimeters. Okay, if the learner passes the end point by adding 5 centimeters of the same hydrochloric acid in excess, calculate the pH. Okay, so basically they are telling us that, guys, the learner used more volume instead of 12.5, but the learner added 5 cubic centimeters more. So the volume of the acid that was used is 17.5, and the volume of the base is simply 25 cubic centimeters. Right, together they want us to find the pH. Already I do know that the volume in excess will be 5 cubic centimeters, so I don't have to worry about finding the volume, the volume which is in excess, right? So all I need to do is to find out the number of moles of my acid which were in excess. How can I do so? Remember that concentration is N over V, so the number of moles of the acid in excess is simply concentration multiplied by volume, right? The concentration of the acid is 0.1. The volume in excess is 0.005. What do I get? Remember that, guys, always the time whenever I use this formula, my volume should always be in decimeter cubed. 0.1 multiplied by 0.005, I simply get 0.005 moles. These are the number of moles of my acid in excess. Okay, since the acid is in excess, I need to find out the number of moles of my ion in excess. So remember that, guys, my acid is a diprotic acid, H2SO4 plus water. This will give me, let me do this, plus water. This will give me 2 hydronium ions plus SO4, 2 minus. Just to balance the equation, I'll just place a 2 there. Okay, so according to this equation, guys, I know that 1 mole of sulfuric acid will give me 2 hydronium ions. But now I do not have 1, I have 0.005. I want to know how much of the hydronium ions will I form. Whenever I cross multiply, I'll find that X, which represents the number of moles of the hydronium ions, is 2 times 0.0005. So the number of moles of the ions in excess is 0.01 mole. Together, for me to calculate the pH, I need to find the concentration of the hydronium ions. Remember that the equation for concentration is N over V. So the concentration for hydronium ions is simply 0.01 we'll divide that. Remember that we have 17.5 of the acid, 17.5 plus the 25 cubic centimeters. That will give me 42.5, né? And then I have to convert the total volume of 42.5 cubic centimeters into cubic decimeters. That will be 0.0425. And then this will give me 0.001 divided by 0.0425. I'll simply get 0.02, let's say 4 mole per cubic decimeter. This is concentration. I don't have space there. Okay, let me write 0.023, let's say 235 mole per cubic decimeter. So now I have my concentration. I can simply find the pH. The pH of my solution is negative log of the concentration of the H3O plus minus the log of 0.0235. What do I get? Minus the log 0.0235. I'll simply get 1.63 as my pH of my solution. Yeah, it's 1.63. So if guys there are challenges with still finding pH, there are videos there, guys, whereby I teach how to find the pH for if you have one acid or two acids in one solution. Same applies with base, one base or two bases in one solution, or a pH after titration. The videos are there, guys. If you are comfortable, just continue answering the question papers with me. Uzoba mnandi. Bye bye.